This is the demo for the PLC Lab. We'll start it off with the logical AND gate, which is only going to be high when both of the inputs are high. So start off with them both low. Just one side high, just the other side high. And then when they're both high, that's when we'll finally see the output be high as well. Now we have the logical OR gate. When either input is high, the output is going to be high, and that output's only going to be low when both of the inputs are low. And we'll demonstrate it really quick. They're both low right now. The output's low. And if either side is turned high, or if they're both high, the output's going to be high. Next we have the NAND gate, which is just an inverted version of the AND gate. So it will be high at all times except for when both of the inputs are activated, I guess is a better word than high. So right now it's high. If we have just one or just zero going, that output's still going to be high, but if we have them both going at the same time, the output is going to be low. Last we have the NOR gate, which is just the inverted version of the OR gate. So it's going to be, or the output's going to be high only when both of these inputs are not activated. As soon as you activate either one of them or both of them, the output's going to be low. For the project part of the PLC lab, I chose an automated parking garage, and it starts off with input 0 here, which is the driver approaching the machine, and the machine turning on is the output. The next part, input 1 is the driver pushing the button on the machine. Input 2 is accepting payment, and input 3 is double checking that the gate is closed. And they're shown there. And input 4 is for the garage being full. So if the garage is full, input 4 will go and it won't let anyone in. Input 5 is the counter, or the input for the counter to check if the garage is full. So right now we just have 5 because I'm not going to sit here and click it 100 times. And once it goes through 5 times, that counter C1 will go high, and an output to say that the counter is full will go high as well. Let's see. Inputs, or for the fourth rung, it's input 6 and 7, and they're for the ticket being removed or credit card being charged with the plates already on file. So if either one of those are high, it's going to go through. And we just chose 2 different gates, so if either one of the gates raises properly, then that output will go through. Let's see. Next one is for just the car clearing the gate. So as long as the car clears the gate, it'll signal that the light can turn off and the gate can go back down. And timer is for any obstruction of the gate. So say the gate gets obstructed, input 11 turns on, the timer counts out for however long they would need it for, and brings that input high, which will bring another output high, which would more than likely trigger an alarm. And that's it.